In this video, we're going to revisit our simple Beatles database, in which we have just an example of a one-to-many and another example of a many-to-many relationship. So we have albums and songs and artists, and album song is going to be one-to-many. We're going to forget about any greatest hits albums. So we're going to say that a song is on one album, but that an album has many songs. And then the artist-song relationship is going to be many to many. An artist writes many songs, and a song is written by many, by meaning more than one artist. And in the Beatles, that's definitely true. Many of them are credited to Lennon and McCartney. Okay. And then we're working with a bridge table. And so that was defined here. And then here's the album with its relationship to song, song with its relationship to artist through the table, and artist with its relationship to song through the table. Okay, and those are just the definitions. And then there was some code for loading. So I had some data files with the album information and the song information, and then I just sort of hard-coded in the Beatles themselves, and also hard-coded in some of the bridge table entries. So this one, for instance, this is really two records. There is a record for Lennon, John Lennon writing the first song, I Saw Her Standing There, and then McCartney giving a second record for McCartney writing it. Then down here is George Harrison writing Don't Bother Me. Okay. And what I really wanted to look at was the queries, and we played in the past with the queries and using the relationships. For instance, do I still have them here? Yes, so here I am getting John, and then I am using the rote relationship, the many-to-many relationship, to find John's songs. Okay, but what I wanted to do here differently than what I'd done before is some explicit joins. So the when we rely on the relationships, they are doing the join, what you call in SQL a natural join, sort of automatically for us. They do that work for us, but there is still SQLAlchemy still supports sort of you doing an explicit join, and that's what I wanted to show here. So here's my first join. I'm doing album to song, so that is a sort of relating two tables, and that's the one-to-many relationship. So I'm connecting two tables here. And so just in my session query, I list, again, because of my separating files, everything has this my_db in front of it. That's when I import stuff from the database, I do my_db. So I'm bringing in album and I'm bringing in song, just sort of comma separated here. And then in my filter, that's where I do the natural join part, making it a natural join by saying that the album.id is equal to the songs.album.id. And that's the work that was done for us by the relationship, but now we're doing it ourselves more explicitly, just to show that this capability of joining. There are joins other than natural joins that one might want to do. And so it's just a way to, another way to do it, to get what we already got out of the relationship, but also just to show that SQLAlchemy does still support this more explicit join. That I wanted to show that. Okay. So the filter is like our where clause, and if we're writing our own sort of explicit join, then it's two tables separated by a comma, and then the where clause is the IDs being equal. I'm just showing here, asking what is its type, and what and then taking the first, I'm getting all of the results, but I'm taking the sort of first result and showing it as a dictionary. And it really has these two properties. We can't, at this level, there's just two properties, album and song. And then if you want to dig down farther, you have to go my first that first record, my join zero dot album, and then you can sort of dig down and start seeing titles and things like that. So let's clear, and this one says the header is like join, so that's what we're going to look for. So do some scrolling up, and where is my first? That's join two. Here's join. And so we said, what is it? It's a row. It's a SQLAlchemy row. That's what the type of thing that comes out of it. So I got all the records, so that would be a list. This is the first item in the list, and it is this row class. And then I said, what does it look at like as, make it into a dictionary, and then I can see, well, there are two properties, album and song, and those properties are themselves objects. So let me then take specifically the album part, the album object, the album value, and then look at it as a dictionary. And then we start to see, here's the ID of ppm, please please me, and there was an image. And so these are all the properties of the album. And it has this sort of like the sequel property in there that we've talked about before. Okay, so that was this first. So it is, we are doing a join. We are explicitly writing the two tables, sorry, and then explicitly putting in the matching of the ID. So we are more explicitly writing our own join rather than relying on the relationship. What I did in join 2 here was name specific fields that I want. So instead of saying grab everything from the two tables, I am specifying that I want the album title and the song title and not everything else. But then filtering. So I'm doing a join, a sort of more explicit join, but not of the sort of full tables, but more of the specifying the columns I want. And then, so that was join 2. Let's see if I can scroll down just enough. Okay. So that was, again, a row. But when I asked what the first items casted as a dictionary, it's, I would say, flatter, that it does not have, before it was to get down to something recognizable like please please me, it was the row and then the album and then the album title. But here, when we've named the fields we want, what comes out is flatter. So it's just all the fields come out and they don't sort of belong to some larger object. They're just two fields coming out. So there's an album title field and a song title field. And then I printed them all out. So there's my big long list of albums and songs. So that goes on and on. All right. Here I am doing, I call it double jointed, my little joke, but this is the many-to-many relationship. And so if I'm listing my tables, if I'm not using my relationship, but doing a more explicit join, then I have 3 tables. The table that corresponds to the song, the table that corresponds to the artist, and then my bridge table. And there is this little C. You got to watch for this little C in the filter. So I have 2 filters. I'm relating 3 tables. So I have to say that the song's ID remember what's in the bridge table is just the ID to connect it to song. So each record in the bridge table has a song ID and an artist ID to say that that artist wrote that song, or at least was one of the writers of that song. And so there's a matching of song ID to the song ID in the right table. And there is also a matching of the artist ID and the artist ID in the right table. But when we're in the right table, we add this additional like .c in there. So not not an obvious thing when you do it for the first time, but that's what makes it work. And again, I'm sort of just looking at the type. So here, again, I went back to I'm not naming explicit fields. I'm like explicitly doing the join, and it is on two because it's a many-to-many. I was working through a bridge table. I am listing 3 tables with 2 filters. But I didn't specify, I wanted all the properties of song, all the properties of artist. And so again, I'm looking at what type of thing I get and looking at it as a dictionary. And again, down here, it's this more layered, structured thing where I go from my row, my record, to song title. So that should be it. Almost there. A little bit up. Here is my double jointed. So it was again a row. When I asked what it was, it says a row. When I write it as a dictionary, it's saying that it's a song, and then this and then the sort of object properties. So it's got these layers. And then when I'm looping through and I have to go through those layers. I have to go from row to song title, row to artist last name. And that's what we see here. And then one last version. I am doing the explicit join, but also explicitly naming the properties I want. And so it is still the last one that I labeled double jointed 2. It's still a row, but when I cast it as a dictionary, again, I'm losing this song and artist level, and it's just giving me this sort of flatter thing of here's the song title, here's the artist. Song title and artist ID, song ID. So it seems like I got a little bit more than I asked for, but and then I got the and then down here it is again flatter. Then I don't have to. Above I went row song title. Here I'm doing wrong, row song title, row last name. So if I name the fields, there's like one less level of to get to the actual sort of piece of data. Well, that's what I wanted to show you, that that there is support for writing explicit joins, having sort of multiple tables with a filter, and then just one weird thing was when I was working through the right table, this little C. And we'd gotten these results before by working through the relationship. So you can work with the relationship, or you can sort of more explicitly write your joins. And you would, if you had some join you wanted to do that was not a natural join, not sort of some predefined relationship in your database, then you would need this capability. Thanks for your attention.